There's number one. So notice I found v of t by differentiating x, and I got v of 3 is equal to 1, which is positive, and then I went on to find a of t, and then ultimately a of 3, which I found out was a negative 1. And then as I walked around, I noticed that a lot of you, I'll do it like this, a lot of you had this stuff. A lot of you had this stuff, right? Some good calculatings and derivatives and such. And then your conclusion looked like this. I'm just going to highlight it. Like you just wrote one word, decreasing or increasing or whatever it was, right? So I want you to be super careful. Did you notice in the wording of the question it said 3 really important words? Yeah, so justify your answer is the strongest possible wording for explain yourself. It's not just a give me a conclusion or just say something. It's the strongest possible way of saying give me a reason for your answer, give me reasoning that leads to your answer, write a sentence that explains why you said what you said, like that kind of thing. So that's the strongest version. And so I think what I wrote up there is probably minimalistic, but I don't think we want to get extravagant either and write a paragraph. That usually creates issues when we start saying too much. But I would say that a lot of you probably said too little because all you said was decreasing. And that was the extent of your justification statement. So please do practice writing a good sentence like that. Okay, so questions on 1. Alrighty. So then number 2 was a implicit differentiation question. I ended up with 3 over negative 1 minus pi over 2. Although if you wrote this like negative 3 over 1 plus pi over 2, I'm sure y'all can see that that's the exact same answer. So that would be just as good. And there could have been a variety of answers too. I mean, I suppose you could have written negative 6 over 2 plus pi, or 6 over negative 2 minus pi. All those would be same thing. So up to you. We're all good. What do you think about number 2? Yeah, no equation of tangent line. It's kind of maddening when you're thinking about a test and you spend all that time, an extra minute or two coming up with the equation. You're like, right? You need to. If you find yourself doing that a lot, draw attention to this. I bet you if you did one of those, you circled that a bunch, you'd maybe have a 50% better chance of remembering to stop at the slope. I don't know, something like that. So questions about 2. All right. So then I lost the top of my pie. There we go. So then the last one was that related rates question. And so here is my solution for that. My solution appears in the lower left. So it's right there. I did a little bit of work off to the side to figure out my x at the freeze frame moment. My relating equation, and I didn't do all the extra setup stuff that you guys probably did, so I mean, you should probably be doing that as far as setting up what we're trying to find and what the other rate would be and all that in the freeze frame moment. Anyway, so the relationship is a trig function, cosine there, and then I did my DDT, plugged stuff in, and I got 0.311. It's a great time for you to ask a question. Where did that number come from? Or well, I thought it should be this. All those are great questions. How did you pick cosine for your relating equation?
Where did the x to the negative 2 come from?
Yeah. So kind of my in-between step there would be that I would rewrite this to be 50 x to the negative 1.
Mm-hmm.
And then the derivative of 50 x to the negative 1. First part is just power rule. And so that's where this comes from. So it's negative 50 x to the negative 2. And then, of course, times your chain rule factor. But it comes from a power rule on that x to the negative 1. Thanks for asking. What else? Surely there's some little detail that's up there that I haven't explained very well. As a human, we all make mistakes, right? We all fall short. So, come on. There's got to be something that I wrote up there that I can clarify for you or something like that.
Would 0.01 be d theta over dt?
Yeah, 0.01 is d theta dt.
Okay.
And unlike you guys, I didn't write out all of my givens as I broke the question down, because I'm old and been doing this forever. But off to the left, maybe I would have had that, right? The rate of change of the angle, d theta dt is 0.01. Right. Yeah, those two, you're correct. Those two do go together. What else can I do for you? Well, while you're thinking, let me just give you a couple of words of encouragement and a reminder. First of all, I look at number 2 on this warm-up. It's a pretty challenging implicit differentiation question, honestly. And I think back to where you guys were 2-3 weeks ago with those. I'm seeing a lot of growth. I'm seeing some really good growth, as in, okay, I can do this, versus, oh my Lord, help me, I can't do it, right? And even number 3 here, I was super encouraged. It's pretty new stuff, but I was super encouraged to listen to you guys talking, peeking over shoulders. You're attacking it really well. You're setting things up, and you may or may not have gotten the perfect answer for this one. But man, you're showing progress, right? And that's all anybody could ask, is you should go from here to here to here, and maybe some days you drop back down to here, but then the next day you go back up to here. You're showing really, really good progress. So please be encouraged. I've been doing this for so long. You guys are doing awesome. You're doing really, really well. Keep it up, and I think you'll see some really good results. Then, second of all, reminders. Remember that tomorrow is review quiz 4, and number 2, I think, was the last eligible question for review quiz 4. Had the RQ4 on it, so please be ready for that tomorrow. And then I believe it's day 4 of this week, so Thursday, we have our quiz on related rates. Okay? That'll make sense? I guess the last reminder would just be that we have our Unit 3 test next week. Unit 3 test next week. And for you guys, that should be on Wednesday. So that's why this week is a prime week for you to be doing any retries that you might need to be doing. It's a great way to study. And hopefully, if you are doing your retries, when you get to that study time, you're like, all right, I've done this literally 50 times, or whatever it is you've done it. Feel confident, ready to go, instead of the crammed section that sometimes you feel in other scenarios. Okay. Did anything else come up for you guys with this? All right, cool. Guess what we're going to do today? Related rates. We're going to do it again. This is our last regular day in class to get this stuff mastered. So let's do it. And I'm going to go in order here. And I would like to do just a little bit of back and forth, interacting with you guys, at least in some part on these. And so please take a minute and read this. I gave you a lovely graph off to the side. I think for sure this would be calculator active. Yeah, it's got to be. Yeah, this is definitely calculator active. I didn't put that there, but it should be. I'll read it out loud for those that want to hear it too. It says, find the rate of change of the vertical distance between the graphs of the functions, the polynomial and the trig function there, if dx dt equals 2 when x equals 1. And we're going to try to interpret the meaning of our answer. Find the rate of change of the vertical distance between the graphs of those functions if dx dt equals 2 when x equals 1. Okay, so has anybody put a box around the thing we're supposed to do? Find the rate of change of the vertical distance. That's right. So that would be here. So we're supposed to find the rate of change of the vertical distance between the graphs. Okay, so then how would we interpret that then as one of those Leibniz calculus variables? What do you think, Luke?
Maybe
dy dt. Let's be super careful with that, and here's why, no pun intended. Look what I circled. And look what I circled.
We'll do dz dt.
dz. Why z? Just because? Something else? Can anybody, like, he's struggling for a variable. He's obviously has the right sense of what he wants to do. Can anybody think of a different variable besides y and z that might be a little more descriptive and informative for us as far as what are we doing?
Maybe d.
Maybe d for
Distance.
distance. Is that okay? So what if we did this? This is what I would be comfortable with. d, d, dt. I know that's a lot of d's, but hopefully that capital D reminds us that we're looking for the rate of change of distance. Okay, this is our unknown. Did you guys see any other rates?
dx dt is 2.
Yeah, for the first time, the word rate wasn't in there to describe the other rate, but that certainly is another rate, dx dt. So that's a very easy interpretation. So that means the rate of change of the x-coordinate is 2. It's like basically the rate that we're moving across these graphs. And then did anybody pick up a freeze frame moment? When x equals 1. What's the key word to identify that freeze frame moment? When. There it is. So when x equals 1, so freeze frame when x equals 1. So the big challenge here is going to be to come up with this relating equation. So let's review all the stuff we have. Capital D stands for vertical distance. X stands for essentially the x-coordinate. And we've got these two functions, the graphs over there. So can anybody think of what would tie all this stuff together? Hunter?
Can't we just set them equal to each other?
Okay, let's try that. So if I say x cubed plus 6x squared minus 3x plus 1 equals sine of x squared, right?
Equal to each other, though.
Say again?
Wouldn't they never be equal to each other?
I'm looking at that graph and I'm wondering if they ever are. And I'm kind of thinking, you know what? There will be a point, because that's a cubic that clearly has a turnaround point. So if a cubic has a turnaround point, doesn't it have to have another turnaround point?
Yeah.
And so this would come back around down to here somewhere. And because that's sine of x squared, I know it's just going to do this. So there would be an intersection point somewhere out there. Is that what we're looking for?
No.
It's not what we're looking for. So that's valid, and we probably could find the answer eventually, probably with our calculator. But I don't think that's what we're looking for. Did anybody notice that something very conspicuous is missing from that relationship?
Why?
Well, those are both y's, right? There's something else really important that's not there.
D.
The d. If I want to find d, dt, doesn't my relationship have to have a d? It's not in there. Okay, so valid and true, but not what we're looking for. So let's keep looking. We're talking about vertical distance between the graphs. We're talking about the two different graphs. And we're talking about the x changing. What might relate all those elements with a d in there? Reese, do you think you've got one?
Would the vertical distance come when you subtract the first function from the second function?
The first from...
Yeah.
So tell me exactly what you want me to write.
Like x cubed plus 6x squared minus 3x plus 1, all in parentheses, minus sine x squared.
So x cubed plus 6x squared minus 3x plus 1 minus sine of x squared.
Mm-hmm.
I still don't see my d in there anywhere.
Yeah.
Equals d.
Yeah.
Okay. Let me create a little more room for myself. Equals D. All right, so what do you guys think of that? You like it? So so basically what Reese is trying to say here is that the vertical distance is equivalent to the difference between them. Does that seem logical? Obviously, it's got all the elements. It's got the D, it's got the X. But does it seem logical that subtracting them would give you the vertical distance between them? No? Anna, how tall are you?
6'1".
So she's 6'1". What if I said, and I'm 5'9". So what if I said, I want to know the vertical difference, the vertical distance between the top of Anna's head and the top of my head. She's 6'1", I'm 5'9", what would you do? Wouldn't you subtract her height minus my height? So I think that makes sense. Doesn't that make sense to you guys? That's why I put vertical distance in there. Because if I just put distance, you could maybe misinterpret that to be like any angled distance between any 2 points. But vertical spells it out and says, we're talking about what's happening in a vertical orientation. I think the only way to do this is subtraction. I think he's found a really good relationship. How do you know that you found a good relationship? A, it involves all the stuff that it needs to involve, namely the D and the X that we already had. And then B, it's got to be true or logical. I think it is logical. Okay, so to use the silly little analogy that I've used in the past, we've picked the movie out, right? There it is. It's the D equals one function minus the other function movie. How do I push play in our little math world? DDT, derivative with respect to time. Remember in a YouTube video or any other video, when you push play, time starts to go. So I'm going to go DDT of everything. I'll come down here where I've got a little bit more room. So I'm going to write dd dt equals, here's where I get a choice, and I want to show you how you could be efficient with this. Do you guys see that every time you did ddt of this, this, and this, aren't you going to get a chain rule factor of dx dt every single time? So why not just do this? dx dt, just factor it out automatically. dx dt parentheses, and then we just do our rates of change inside. Does that make sense? So I would write 3x squared plus 12x minus 3 plus 0, technically. For that first term, does that make sense? You can write out the dx dt 3 times if you want, like you could distribute it essentially, or you could just mentally factor it out. To me, that just seems a little bit easier. Minus, what on earth is the ddt of sine of x squared?
2x sine.
So 2x, I agree with that part.
2x cosine x squared.
Cosine of x squared times,
dx dt.
that chain rule factor is still there. So the 2x is a chain rule factor. dx dt is the other chain rule factor. All right, so I'm really hoping now that we have this DDT, we've pushed play, we're going. I'm hoping that you can see how I think everything is going to drop right into place, isn't it? You plug in a 1, you already know dx dt is 2, and I think we can arrive pretty easily, with our calculators at least, at a nice answer by plugging in. So 2, and then x is 1 at the freeze frame, so it'd be 12. So I think with everything plugged in, it would look something like that. Anybody have a decimal approximation for our answer? The decimals were 8 what?
839.
So 21.839. So at least 2 people think that. That answer seems logical because 2 times 12 is 24 minus something. What kind of units did I give you for this? I didn't really give you any, did I?
No.
So We're just dealing with the graph units. I didn't even give you any time units, so I think we just leave this one unitless. Say most of the time your related rates questions will have units attached, but this one maybe not. So how we doing? Seen this a lot. I'm going to show you one more, but before I do you have any questions? Yes, ma'am.
How do we interpret the meaning of the answer?
Oh, sorry, I forgot about that. Let's discuss. So interpreting the meaning of the answer. So dt is 21.839, and we want to be precise on that. We want to have a good answer. What's the other really important thing about that answer? Say again? At x equals 1, right. But as far as the 21.839, there's one aspect about that as far as what the answer means we want to bring out. That number is?
The distance between the two.
No, it's the rate of change of distance. And the rate of change of distance is? What kind of number? Positive. So therefore, what would be your meaning, Tyler? What's increasing? Yeah, the distance at that particular point is increasing because the rate of change of it, the distance, is positive. Well said. Well said. So Tyler fell victim to the one-word explanation. He just said, increasing. Make sure you identify what is it. He was obviously right on it. He just needed to say it a little more fully, but he was on it for sure. Kaylin, thanks for asking. I was going to just totally forget about that. Anybody else? Okay, then. We'll finish with another water tank. Yes. Except this water tank is unique. This water tank is conical. It's shaped like a cone with the vertex down. So this tank is 10 feet across the top and 12 feet deep. Water is flowing into the tank at a rate of 10 cubic feet per minute. We're supposed to find the rate of change at the depth of the water when the water is 8 feet deep. When you start to read this and you start to try to break it down and pick it apart and do all that good stuff, are you guys okay with me saying that I think a picture would be really nice here? Picture? Okay, so I'm going to try to sketch that out. I'll do this off to the side. Sorry, I keep getting emails. So here is my conical tank. And then I'm given some dimensions on this tank. I'm told that it's 10 feet across up there at the top, and it's 12 feet deep, like so. And then it's being filled with water, and so maybe I represent that with just a little bit of blue down here. Something like that. I don't know. There's my very rudimentary picture. One thing that's interesting to think about here is when water flows into a container like this, doesn't the water automatically take on the shape of the container? So we basically have a cone that's a tank, and then somewhere in there, don't we have a cone of water? Okay. So think that through. Okay, let's put a box around what we're supposed to find. What did you guys identify as the objective for this? Rate of change of the depth of the water. That's right. So put a box around that. Find the rate of change of the depth of the water. That makes sense. Can you think of maybe a Leibniz calculus-y kind of variable that we could use here that would make sense and be what we want? D, dt. D for depth. Okay, fair enough. So d, dt, that's our unknown. Trying to find the depth, the rate of change of the depth of the water. I can buy that. Okay. Did anybody see any other rates that are happening here? There's got to be at least one more, right? And what are we talking about? Like, what kind of thing is that? Water is flowing into the tank, and there's that word rate again. That's key. What is that? It has to do with volume, doesn't it? How did you know about volume, Jed?
Cubic feet.
There it is. Yeah, cubic feet. That's a volume unit. Okay, so then what kind of a Leibniz variable would make sense here? F? Oh, for flow, but yeah. I think I would go with a different one.
You could do like.
I'd say V. There's no out though. I think there's only flow in.
Oh, it's not. Okay.
This is not a water
It's gonna be
tank.
a net rate.
This is not the classic water tank question, right? We've looked at where there's flow in, flow out. There's just flow in on this one.
That would be
Later
a
on, we'll
question.
poke a hole.
Yeah, that'd be a good question.
It would be a different question for sure. We could do it. There would be a third rate involved. In the end, it'd be slightly more complicated. Yeah, in the end, it'd be pretty similar. Okay, so dVdt is equal to 10. Why would I be okay with having that be a positive 10?
Because it's coming in.
Yeah, volume is increasing due to that rate, right? Water's flowing in. How about a freeze frame moment? There it is. Yeah, when the water is 8 feet deep. So when what is 8? D, depth. There we go. So when depth is 8 feet. Okay, so I'll give you a moment here to think this through. We're trying to come up with our relating equation. It's got to involve the fact that we've got a cone, and there's depth, and there's volume. Okay, you've got a cone that has depth, and it has volume. Can anybody think of what might relate all this stuff together? What do you think, Hunter?
The difference between the two volumes.
I think you're going way too far. Let's focus on one aspect of that. One aspect. What do you think, Nate? Volume equation for a cone's volume, which is?
1/3 pi r squared
Yeah, keep going.
times the height, or d.
There we go. That is actually a pretty nice find. Good job, Zach. Volume equals 1/3 pi r squared. Now, the classic is pi r squared h, where h is the height. But how would we adapt that for what we've done? D instead of h, right? So I get this. And this is where this one gets a little more challenging. And I want you to think one step ahead. We've got our movie picked out, right? There it is. It's the right movie. The only problem with this movie is there is some objectionable material. And we might want to watch the censored version of this movie. And I'm being sort of silly, but I'm not at the same time. If I were to think one step ahead, if I was going to do ddt of this, ddt, let's think what would result if I did ddt? dVdt. Is that something that I either want or have? I have it. So dVdt being in there, that's good.
Do you just want to get d by itself?
Hold on. Just play through this movie with me here. So the fact that we would get dVdt, that's a good thing, isn't it? If I did ddt with this, what would result? Is that something that I either have or want?
No.
That's some pretty objectionable material. That's like, pardon the illusion here. I'll just say it like this. If this seems rude, I do apologize. But you know those movies that are like perfectly good movies, and there's like this gratuitous nude scene in it, and you stop and think, why was that in there? There is no good reason for that to be in there other than for, let's just be honest, a bunch of foul-minded people to say, ooh, there's this nude scene in it. You should watch it, right? It's a waste of a scene. You know what I'm talking about? Or a movie's going along perfectly fine and there's just like some seriously horrible language and you're just like, why? Like, honestly, why did you feel the need to put that in there? It's unnecessary. We don't really want it, right? So we want to get rid of it. Luckily in math, we have a way to get rid of this. So check this out. We're going to edit this movie a little bit. The fact that we have two cones makes the difference. Let me redraw these cones, but in a very two-dimensional way. There's the big tank, and here is the water. Can you guys think of a way that I could create a nice substitution? What could I set up? In fact, I'll fill in some more for you. Isn't this from here to here? Isn't this a 5? And isn't this a 12? I'll keep going. Nobody's saying anything. What's this from? What's from the dot to the outer edge of the water?
The radius.
That's a radius, and that's changing all the time, isn't it? Okay, and then how about from the dot to the bottom of the cone? What's that?
The right?
No, that's freeze frame moment.
That's the freeze frame. So this,
That's all. That distance is always changing until we get to 8, right?
right. So that's gonna be D.
That's D. Anybody figured it out yet? How do I relate this stuff together to help me?
D over R equals 12 over 5.
Can I set up a proportion? So here we go. I'm going to come over here and say I need another equation. D over R equals 12 over 5. What was the objectionable thing? What didn't I want in my movie?
5.
I don't want the R. It's R-rated. Don't want it. Ha ha ha. Yeah, that was hilarious. I know. So this would be, what, 5/12 D equals R? I think I did that right, didn't I? Multiply both sides by 5/12 and multiply both sides by R. Get the R by itself. So what I can do then is I can come back to my movie and say, oh, there's a part in there I really don't want to be watching. And if you watch movies and you never ask yourself, do I really want to be watching this? You're being foolish. Here's my editorial for the day. I've replaced my R with some less objectionable material, like 5/12 D. Okay. So then I simplify this a little bit. I get 1/3 times pi. This would be 25 1/44 D cubed. Now when I push play, there will be no more R-rated material. It'll just be V's and D's and T's. I realize we're right up against our time. This actually finishes very quickly. So DDT, what's DDT of V? dVdt. Do y'all realize that 1/3 and pi and 25 1/44 are all constant multiples? So I can basically cover those up mentally and just write 1/3 times pi times 25 1/44 times the derivative of d cubed, which would be 3d squared times d dt. Those should all be uppercase D's, sorry. I think you get it. And then it's just a matter of plugging stuff in, right? You know that dVdt is 10. And you know the freeze frame moment is when D is 8. So that's just a matter of doing some multiplication and division. What would be the units on dt? Not feet squared. Not feet cubed either. Feet per minute. Yep, it'd be feet per minute. Okay. I thought we were going to finish it. We came within a minute. You guys are all free to go. Have a great rest of your day. I will see you mañana. Luke, your question.
Do you have our
Oh, darn it. Yep, I want to hand those back to you. I'll get those on the way out. There's always so much